This is on exponential growth and doubling time word problems. Any situation where something grows exponentially can be modeled as a doubling time using this formula here. So the formula has the final population is equal to the initial population times 2 to the exponent t over dt, where t represents the amount of time that has passed since its population was the initial population, and dt represents the doubling time. So there are always 4 variables in an exponential growth problem: initial population, final population, the amount of time that has passed while it's growing, and the doubling time. And you can only solve for one of these if you know the other 3. So let's have a look at an example. Okay, in question 3, it says a bacteria culture starts with 3,000 bacteria. After 3 hours, there are 48,000 bacteria present. What is the length of the doubling period? So I'm going to identify my variables here. It starts with 3,000, so that means the initial population is 3,000. After 3 hours, so that means time is 3 hours. There's a population of 48,000, so the final population is 48,000. And the only unknown here is what is the doubling time. These variables are all related with this formula. The final population is the initial population times 2 to the exponent t over dt. So 48,000 is equal to 3,000 times 2 to the exponent 3 over dt. And all we have to do now is solve for dt. The strategy I'm going to employ is first I'm going to solve for 3 over dt, and then I'll have a simple linear equation to deal with. So isolating this is my goal here. To achieve that, I'm going to divide both sides by 3,000. So we have 48,000 divided by 3,000 is equal to 2 to the exponent 3 over dt. 48,000 divided by 3,000, or the same as 48 divided by 3, is equal to 16. So 16 is equal to 2 to the exponent 3 over dt. Okay, so that came from here. We started off with 48,000, the final population, was equal to 3,000, the initial population, times 2 to the exponent t over dt, time over doubling time. 48,000 over 3,000 is 16. So now we have 16 is equal to 2 to the exponent 3 over dt. Now I'm going to solve this in 2 ways. We can easily solve this in our heads without using a calculator because 16 happens to be a power of 2. But I'm going to show you how to do this using logs, just in case you don't have numbers that work out so nicely. So at this point we'll take the log of both sides. So I have the log of 16 is equal to the log of 2 to the exponent 3 over dt. And we have a rule with logs that allows us to bring this exponent down here, turning it into a linear equation. 3 over dt, well, the variable's on the bottom, so it's not technically a linear equation, but it is easier to deal with. 3 over dt times the log of 2 is equal to the log of 16. Now I can multiply both sides by dt and divide both sides by the log of 16. So dt is equal to 3 log 2 over the log of 16. And the answer is 0.75. So the doubling time is 0.75 hours, or 3/4 of an hour, 45 minutes. Now from here, we didn't really need to use logs. I'm going to solve this now a second way. 16 is 2 to the exponent 4. So I can rewrite 16 as 2 to the 4. So 2 to the 4 is equal to 2 to the 3 over dt. With the same base, the exponents must be equal to each other. So 4 must be equal to 3 over dt. And simply rearranging this, we end up with dt is equal to 3 over 4. The same answer that we got when computing the logs.